Now the question is, why do you think that carboxylic acid have higher boiling points than those of alcohol? It is because of hydrogen bonding. Alright? Carboxylic acid has a tendency of forming extensive hydrogen bonding. Is that okay? With each other. Hence, they need a higher temperature for them to what? To boil, for the intermolecular force holding them together to be let loose. Is that okay? Now their solubility increases as the chain increase. Now when we talk about their solubility, it means that methanoic acid will be more soluble than what? Than propanoic acid. Now you must always know that when we talk about boiling point of carboxylic acid higher than those of alcohol, it must be those of the same molecular weight as those alcohol, not just a random carboxylic acid. So they might give you let's say propanoic acid, and then they now give you, let's say, heptanol. These two things are not of the same molecular weight, so you cannot compare these two things together. Is that okay? That is that. Now, reaction of acetic acid. Let's look at acetic acid. The one we looked at initially was methanoic acid, but let's look at acetic acid. Now, all the reactions will still be the same. That's why I just said once you understand one, every other thing becomes easy. Now with sodium bicarbonate, I'm not going to waste time here because I'm going to be rushing very quick through these ones. With sodium bicarbonate, what did I say when sodium bicarbonate react with carboxylic acid? What are they going to form? They are going to form the salt, because sodium bicarbonate is a salt, right? So, and I told you that this is one of the means of testing for what? For acetic acids. For the acid generally. This is going to form the salt. So you are going to form sodium salt of carboxylic acid, which is sodium salt of methanoic acid, plus is going to form CO2 plus water. Told you that. How do you confirm the presence of this carboxylic acid now? Is this CO2, you pass it through lime water, and the lime water will become milky. Right? Did we discuss something like that? Exactly. That's one of the way of actually testing for the carboxylic acid. Now, let's look at another one. Reaction with phosphorus pentachloride. What did I say when you react with phosphorus pentachloride? It's going to substitute the OH with what? Chlorine. So you see that everything is still the same. So with phosphorus pentachloride, so here we give us CH3, COCl plus what? POCl3 plus what? HCl. Alright? So that is that. So this is called ethanoic chloride or acetyl chloride. This one here that is formed. So that is that. Now, how about reaction with ammonia? What do you say about reaction of acid with ammonia? It's going to form the amide. It's going to form what? The amide. So this one now is just acetic acid. So everything we did for formic acid is still being replicated here. So first of all, we say this one is going to form the ammonium salt, which is going to give us something like this. And then when you lose water from here, when you lost a molecule of water from here, it's going to give us CH3, C double bond O. Here will be what? NH2. It's going to form an amine. And what is the name of this amine that is formed? It's called acetamide. Alright, so that is that. How about phosphorus pentoxide? Now, when you react it with phosphorus pentoxide, it's going to form acid anhydride, something that we've learned before when we are talking about the carboxylic acid general reaction. Whenever you react it with phosphorus pentoxide, just remember that whenever we are talking about this phosphorus pentoxide, it's going to form an acid anhydride. So you have two molecules of acetic acid, because two molecules of acid condensing together will give us an acid anhydride. Then you pass it to P2O5, which is phosphorus pentoxide. Water molecule will be given off. We've done something like this before. So when water is given off, what do you think will now be the product here? It will be CH3, C double bond O, and then here will be what? CH3 plus what? Water. Now when this water in a reverse reaction adds to this, is going to give us the it's going to give us the 2-carboxylic acid again. So this is called acetic anhydride. Alright, so that is that. Now let's see the next one, reduction with lithium aluminium hydride. Now when you react with lithium aluminium hydride, it's going to give us the corresponding alcohol. So you have lithium aluminium hydride, like I told you, is the only is one of the best for reduction of carboxylic acid. Let me not say it's the only, because I believe there are other reducing agents. So to reduce the carboxylic acid, in this case this is acetic acid, which is ethanoic acid that we are looking at. It's going to reduce it to give us ethanol. So here will be CH3, here will be CH2OH. What is this? Ethanol. Alright, so that is that. Now the next one is, we've actually looked at something like this. When treated with chlorine or bromine in the presence of red phosphorus, we say when we treat acid with chlorine or bromine in the presence of red phosphorus, it will form the alpha product, alpha halogenated product. Did we learn something like that earlier? Yes, I did. So if we look at the CH3 COOH now plus, let's say, chlorine, passing it through this, is going to form the alpha halogenated product. So if you see something like this, chlorine treatment of chlorine with this, the presence of red phosphorus, this carbon here is the alpha carbon, so it means one hydrogen here will be removed, will be substituted with chlorine. So you are going to have, instead of CH3, you are going to have CH2 with the chlorine on top. Then you have COOH plus, you know, hydrogen left here, there were 2 chlorine here, one react there, so you add the other chlorine to it, then it gives us chlorine, ACl. So this is what? Chloroacetic acid. You can say 2-chloroethanoic acid, 2-chloroethanoic acid, 2-chloroethanoic acid, or you can say alpha chloroacetic acid, alpha chloroacetic acid. Alright, so that's basically how to go about that one. Now let's see, methanoic acid will produce silver mirror. Now the same way it produced that, it's still the same way you can also react it with phosphorus. Phosphorus too, but this one is propanoic acid. Now you know we are talking about ethanoic acid, but let's just look at it because it's part of your material. With red phosphorus, still the same thing, but then you now have to spot the alpha. Here is the alpha carbon, here is the beta carbon, so it means substitution will take place at this position. So what are you going to have? You are going to have CH3, then here will be CH, one hydrogen will leave, bromine will attach here, then you have COOH plus what? HBr. Is that okay? So that is that. Now differences between methanoic acid and ethanoic acid. Now one thing that you should know is that methanoic acid will produce silver mirror with ammoniacal silver nitrate, but ethanoic acid does not. I've explained why, because we said methanoic acid has the what? The ethanol functional group. Are you getting it now? It has the aldehyde functional group. That makes it to act as a reducing agent. Did we learn something like that? I told you something like that, right? So if you have something like this, then you have 2 silver, and then you have NH2, 2NO3, right? Told you that this one is going to give us 2 Ag. It reduces the silver ion plus CO2 plus 2 molecules of ammonium nitrate plus 2 molecules of ammonia. Now this is the silver mirror test. This formic acid is capable of reducing this silver Now, one thing you should know is that this one is usually have a valency of 2. To reduce this to what? To silver with a valency of what? 0. All right. So it acts as a potent reducing agent, and this one is going to give us a silver mirror. Silver mirror. So it actually produce silver mirror with ammoniacal silver nitrate, but ethanoic acid does not. So that is one of the discrepancy. Now, another thing is that formic acid reacts with mercury chloride to produce white precipitate. Acetic does not react with mercury chloride to produce white precipitate, but acetic acid does not. So these are some of the differences between this one and what? Acetic acid. CO2 plus 2HCl. Now they gave you a question here. Giving acetic acid, ethyl alcohol, acetaldehyde with chemical test. What chemical test will you use to identify each of them? Now, acetic acid, and then give the IUPAC name. What is acetic acid? They want you to give the IUPAC name of acetic acid. It's ethanoic acid. Now, what chemical test do you think we can use to identify ethanoic acid? Now, you can use sodium. Now, you can use you can use this test here. Any of the reaction above, you can actually use it. But the characteristics reaction of acetic acid is the one where I told you that acetic acid will react with sodium hydrogen triazocarbonate to give what? To give the sodium salt plus what? Plus CO2 plus H2O, where I later said that this CO2 now will turn, is a gas. If you pass it through lime water, it will turn the lime water to milky color. Alright, so that is one of the ways to actually identify this one. Then another one, the next one is ethyl alcohol. Ethyl alcohol is something like this. Is called ethanol. So the chemical name is ethanol. What way do you think you can identify it? By reacting it with, so you can react ethanol with thionyl chloride or PCl5. Alright, so if you react this is going to remove this OH from here. According to what we'll be learning since, here will be Cl, and then you're going to have POCl3 plus hydrochloric acid. This is a gas. Now the presence of this hydrochloric acid gas will actually help us to identify them. Then for the last one, acetaldehyde is called ethanol. You can use silver mirror test to get ethanol or Ferlin's reagent. It's either you use the silver mirror test or you can use Ferlin's reagent to distinguish ethanol. Are you getting it now? So that is that. Now, we'll see in the next one. Those are the carboxylic acid derivative. Now, what is the carboxylic acid generally? Their functional group is ROCO. Let me put it this way. ROC double bond O, OH. Now listen. When this OH is replaced with NH2 with Cl, alright, and with other functional group like ORO, alright, can be replaced with bromide, can be replaced with something like this, the ester, alright, it forms the carboxylic acid derivative. Is that okay? So the first carboxylic acid derivative we are going to look. So you have something like the C double bond O NH2. This is the amide, right? Then you have RO C double bond O Cl. This is the chloride, halide, acid halide. Then you have RO C double bond O OR. These are the esters. then arrow C double bond O, O C double bond O arrow. These are the acid anhydride. So these are the various derivatives of the carboxylic acid we are going to look at in this lecture. This one is the amide. Then you have the acid halide. This is the ester. This is the acid anhydride. We are going to be looking at each of them, starting with the acid halide. Now, the most important group here are the chloride, the acid chloride, which is something like this: arrow C double bond O Cl. For instance, acetyl chloride, which we have as something like this. Now, how are they prepared? General formula of the acid halide generally is something like this, where S can be chlorine, can be bromine, can be iodine. All right. Now, general method of preparation is very easy. I've said it before. And the general method of preparation is by reaction with thionyl chloride, PCl5 and PCl3. So when you react with the carboxylic acid, like when they call them carboxylic acid derivative, it means you got them from the carboxylic acid. Is that okay? When you hear of the word carboxylic acid derivative, it means derived from or gotten from the carboxylic acid. So you have CH3, C double bond O, OH. When you react this with the thionyl chloride, it's still going to, this OH should be substituted with Cl. Then you have C double bond, CH3, C double bond O, Cl plus SO2 plus HCl. Is that okay? Now, the next one is CH3, C double bond O, OH. Can be prepared by any of these means, PCl5. This one is going to give us CH3. All of them are going to give us the same product, Cl, but the other part of the product is what we differ. This will give us SO2 plus HCl. This will give us POCl3 plus HCl. All of them are always giving what? Are you getting it? And then the last one is when you react it with PCl3, it's still going to give us the same product. But what we differ now is this one will form phosphoric acid. All this one form hydrogen chloride, but this one will give what? Phosphoric acid. Is that okay? Now, let's look at some of the reactions of the acid. Now, the acid chloride, they undergo substitution, nucleophilic substitution reaction. All right, they undergo nucleophilic substitution reaction. Now, what is the mechanism for their nucleophilic substitution reaction? You have arrow C double bond O Cl. So if you have a nucleophile here, now what will happen is this one will attack here. Of course, you know this one will come up. So this is going to form arrow CO negative. Nucleophile will be here and then Cl. Now somehow this negative charge will kick in back into here, and the most vulnerable group will kick out, and the most vulnerable is chlorine. Chlorine is a good living group. So this will give us arrow C double bond O, and here will be our nucleophile. Chlorine will no longer be there again, so you are going to form plus chloride ion. Is that okay? So if we want to rearrange this, it's going to give us arrow C double bond O and nucleophile. So you discover that the nucleophile has removed chlorine. So the essence of almost all the reactions of acid halide or the acid chloride is to remove chlorine from there, and then whatever that is coming in, we substitute it in. Now, example of this reaction is reactions with water, hydrolysis. Now, chlorine is displaced. So when you react it with water, chlorine is removed. We don't want to go into the mechanism, but just know that chlorine is removed. So what do you think will happen here? It's very easy. Chlorine reacts with hydrogen chloride, right, to form HCl, and then OH we attack here. Here will be CH3, C double bond O, C double bond O, and here is what? OH plus HCl. Now that is one of the reaction. Now the other one is reaction with alcohol. Still the same procedure.